I'm Tom Banchoff, and welcome to my four-dimensional world. This is the gallery of the Granoff Center at Brown University. We have a conference, an exhibit that's called Beyond the Box. Thinking outside the box is all right if you're in three-dimensional space, but you want to go beyond that, to get beyond the confines of three dimensions and then get a new view of the world that we do live in. What we see behind us is the icon for the fourth dimension, an unfolded four-dimensional box. And to understand what that is, we have to come through the gallery. And as we come through the gallery, we see the largest representation of this four-dimensional box that I think has ever been built. The object itself is made of 8 cubes, each cube 3 feet by 3 feet by 3 feet, so that indeed what we have is an unfolded four-dimensional box. To understand how that can be and understand how it is that this became such an important icon for the whole subject, we can go back to a smaller version, a lower dimensional version, and if we unfolded it, it would form a two-dimensional cross, a net for the cube. We could put it back together to form a three-dimensional cube by moving into the third dimension. We started in the second dimension with an instruction set, put it together to form the third dimension. Again, taking it back out, we have the net of the cube back in the second dimension. It is a model of my own design, part of my PhD thesis actually, which required building something which could be folded into a fourth dimension. It starts out with 8 cubes, like the large model we have, but this has flexibility. This belongs on this side. This object itself folds flat. Very convenient for carrying, but also convenient for showing how we go from the second dimension to the third dimension to open up the cubes. And we want to continue to take this into the fourth dimension by identifying the different pieces as in the color coding that appears in the version of this icon in our poster for Beyond the Box here at Brown University, where this fourth dimension has been a central symbol in a series of courses, the original modes of thought courses in the so-called new curriculum back more than 45 years ago, and the current first-year seminars which study this subject from so many different points of view. This particular icon was central to my favorite surrealist painting. Because of that, I was able to meet my favorite surrealist artist, and we can see how that goes, again, by seeing part of the display. I arrived at Brown in 1967 and started working almost immediately with Charles Strauss, computer science, contemporary of mine, who worked with me to realize the fourth dimensional concepts and fourth dimensional objects using computer graphics. Because of this, an article was written about our work in the Washington Post in 1975, in January, showing me holding my unfolded cube, and in the background, a picture of a famous surrealist painting, Dali's Corpus Hypercubicus. I was a little bit worried at that point because I knew they didn't have a chance to get permission from the Museum of Modern Art, the Metropolitan Museum, to show that figure. A little bit later we got a call from someone representing Salvador Dali, and it turned out that Salvador Dali had seen the article in his clipping service. He wanted to meet us, and we visited him for the first time in the picture shown here in 1975 at the St. Regis Hotel in New York City. That led to a series of 10 different years worth of visits when he would come to New York or Paris or Spain, and we would actually come and compare works that we were doing at the time. The original painting, which started the whole thing, was painted in 1954. This is Corpus Hypercubicus. I saw it in 1955 when I visited the Metropolitan Museum of Art, and I was already impressed by it. When I brought this little print from the Metropolitan Museum, Dali said, "Let me sign that." So in 1976, this is the signed version of the print that inspired the concept of unfolded four-dimensional objects and started our collection, our connection with the most unusual artist you'd ever want to meet. This wall of our gallery provides kind of a retrospective of the work on computer graphics and higher dimensions. Our first show in 1976 in February was at Harvard University, the Carpenter Center for Visual Arts, in conjunction with Harriet and David Brisson from Rhode Island College and from Rhode Island School of Design. The first time that our films, Thomas Banchoff and Charles Strauss, were shown in a public place or in an art gallery. But that was just the beginning. In 1976 as well, in April, we gave a series on liberal education and the life of the mind. So the fourth dimension and the life of the mind in the Dean's Convocation series featured one of the figures which was inspirational to us, the inside of a torus. In 1984, when we had a 3-day conference to celebrate the 100th anniversary of the most famous book in the subject, Flatland, Malcolm Greer at Rhode Island School of Design was the designer of this poster, which figured a 3-day symposium with people from all sorts of different fields. That kind of work among disciplines became characteristic of our work here at Brown University and the basis of our show today. Some of the original figures were wireframe models, and this one was the very first poster that Charles Strauss and I did, the Veronese surface projected from forespace. This figures prominently in the retrospective that was done in 2002, 24 years after 1978, the first time that computer graphics films studying objects in fourth dimension were exhibited at the International Congress of Mathematicians, this time in Helsinki. 24 years later, we took the original objects, these wireframe models, in the background and showed what had happened in the intervening 2.5 decades to show the figures that we were studying now, the same objects, but from a totally different point of view as technology increased and gave us new features that we could study. So this was for the International Congress, Satellite Congress on Mathematical Sciences in Beijing in 2002. This is joint work with David Cervone, my former student and longtime collaborator in computer graphics. The objects here, again, are current technology. The inside of the torus that we saw before showing up in this position here, and over in this picture in the process of being unfolded in four-dimensional space. The process of being unfolded in four-dimensional space gives something which is starting to open up and ultimately completely opens up to fill all of space, dividing all of space into two congruent pieces. Another object here is from our show, the show that we had at the Providence Art Club in 1996, which is still available online in a virtual version. We move into the current situation where our current research using technology that's been developed relatively recently starts with an old project that we did back in the 80s representing the three-dimensional sphere, the boundary of a four-dimensional solid object, as a collection of 10 different truncated tetrahedra. The way those things fit together is very, very symmetric up in four-dimensional space. And we see this in pictures made in collaboration with Charles Gunn at the Technical University in Berlin, someone with whom I originally collaborated back in 20 years ago when David Cervone worked along with Charles Gunn at the Geometry Center at the University of Minnesota. This configuration is really quite nice. It's even nicer if you see it as a film, but the stills indicate how these objects themselves, the truncated tetrahedra like the green ones, there are two greens and two reds, and those are connected on a circle, which is colored green and red. So the color coding here really shows the wealth of interconnections up among these pairs of objects, the yellows and the greens connected on the green circle and so forth. A different view of the same object gives us some idea of the relationship between circles, great circles on the great three-dimensional sphere in four-dimensional space, quite analogous to what we study when we study the geometry of great circles like the equator on the Earth in three-dimensional space. Again, analogy is the entire story, and this is actually done very well on a wonderful poster done by one of my former students and an assistant, Catherine Lau. It's very nice to have this in the exhibit because a person looking at these things will say, what is the fourth dimension? We have to explain to them that the fourth dimension can be time, but time is only a fourth dimension. The spatial fourth dimension is what we're exploring here, and the analogies, including the unfolded cross, are explained so nicely by Catherine Lau. 45 years among disciplines is a challenge to represent. Lisa Waltuck is a professional artist who began at Rhode Island School of Design and has produced a tableau to indicate the progression through different stages of development. What we have here is a diagonal that indicates key people here at Brown University with whom I've collaborated over the last 45 years, starting with Gerald Shep Shapiro in music department, Richard Fishman in the art department and the director of the Granoff Center here, the Center for Creative Arts Council, Julie Strandberg, theater, speech, and dance, Tom Webb from geology, talks about paleoecology, and Arnold Weinstein in comparative literature talks about Faulkner and Boutour, and also, most recently, a visitor in my class for Slaughterhouse-5. In each of these cases, there was a collaboration. Professor Shapiro and I did a piece called Fronts and Centers 25 years ago for the dedication of the CIT, the Center for Information Technology here at Brown University. Richard Fishman and I, back in the 1970s, 71, did a wonderful collaboration in a Modes of Thought course in growth and form and mathematics, biology, and art with a bioengineer, Peter Stewart. Julie Strandberg's piece, Dimensions, has been shown several different times in 1983, 1987, 1992. It began really as a collaboration when some of my students in the fourth dimension course were taking the modern dance course from Julie Strandberg. Tom Webb's work appears in the book Beyond the Third Dimension, built from a number of courses that I taught at Brown University, again in collaboration with other people. His work on paleoecology translates time into space by going into dry lake beds through a bore that will tell exactly what the vegetation was 15,000 years ago. Arnold Weinstein, again, has talked about time and space in literature, and again, looking at events from different points of view. Of course, this is related as well to physics. The very first Modes of Thought course I taught was with Professor Fred Bishop, who was in applied mathematics at the time and interested in relativity theory. representing the computer science department was one of my student assistants, David Laidlaw, who took several courses from me, was my assistant, my collaborator, co-writer, and co-producer of film by the time he got his master's degree. He's now a full professor back here at Brown University in computer science, and I teach his son in my courses in the multivariable calculus and linear algebra. The same course their father took back in 1979, 80. Other students from that period of time are David Salazin, now at Adobe, and Morgan Spalter, a very, very well-known artist in computer graphics in the second dimension. Cassidy Curtis, a supervising animator at DreamWorks, and Laura Dorfman, who both in English and in math became the project editor, electronic materials developer at Cambridge University Press. The other diagonal here is my own mentors. R. Catesby Tolliver was my undergraduate advisor at Notre Dame. The master teacher, Arnold Ross, was my first master advisor when I taught in the summer program at Notre Dame. At Berkeley, I studied with Professor Xing-Shen Chern, my thesis advisor. As a postdoc, I was a Benjamin Peirce instructor at Harvard, where I was teaching in the general education program and got to know Eric Erickson, whose work about the development through different times in a person's career inspired this. At the top is Nicholas Kuiper, a person my advisor, Professor Chern, introduced me to. He said, "You must meet him because you two think alike." He was a geometer par excellence, and indeed a wonderful friend and collaborator. 45 years among disciplines. One of the additional models that's featured in our show has to do with building reasonably complex things from very simple models, or very simple modules. Here the modules are triangles, and all the triangles are identical, that is to say congruent, placed in a network that folds up into an icosahedron if you started with simple equilateral triangles, but with one precise form, it folds up into a figure with exactly 8 faces. This particular object, this unique object, is something that really was related to the second project that I ever did with Charles Strauss back in 1970s, and was completed by my student Ezra Miller, my assistant, and who's now full professor at Duke University. So this is the representation of that object, and really is something that was able to be hung, but now resides in a more stable position. Again, something that originally discovered through computer work that we can represent in three-dimensional world. Alain Lieberman was the sculptor who helped to create this object. In this case, built by Ben Kaplan, and who was the co-producer of the largest icon that we see, the large hypercube. This display case was featuring 2 of the outstanding projects that we had as a result of the Fourth Dimension course. One, by Deb Grossberg, is called A Cube Comes to Brown. It tells the story of a cube in my class, and over 23 pages gives a full rendition of all the topics we covered, ending up with a cube ascending into the fourth dimension and me going with him. Deb Grossberg herself went on to become an architect, and now is also a teacher of architecture. Dimensional Geographic was a dossier put together by Sudarat and Larlarb, who was in my class back in 1990. Her work collected together, she put together in her creation of a dimensional geographic. And a dimensional geographic, like National Geographic, should have a centerfold with a map, and the map here is the map that does the planiverse, one of the texts we covered by Key Dewdney, completely folded out here. Sudarat and Larlarb, who now teaches at Carnegie Mellon University and is a specialist in set design and costume design. The other case we have here includes some artifacts from calculus courses that study 3 and 4 and higher dimensions. So in one case, a famous piece called "The Best Homework Ever?" which appeared in the Brown Alumni Monthly and still shows the work of Cassidy Curtis when he was a freshman. What I consider the most impressive piece of mathematical visualization at that level, or at any level, at any time ever, ever, ever. Later on, he became an expert in the techniques of drawing popularized by my colleague George Francis from Notre Dame many, many years ago. And these are from the topology course, where his strange immersion is really a masterpiece of that field. The other objects here are created to exemplify things. A student in 1973 at UCLA, when I was teaching there, had his sister create a Velcro Mobius band, which comes apart and comes back together again. That's been a staple in my topology courses ever since. The Air France Cup from Air France inspired one of the early geometry problems, which was used over and over again throughout my teaching career. A square on the bottom, a circle on the top, a certain height, convex hull, the most efficient way of having a circle and square together in this form. What is the volume? Generations of students have cut their mathematical teeth on that particular problem. A picture, not the object itself, is a picture of the largest package ever sent through the mail. It's 3 feet high, 6 feet around the top, and was actually mailed from one side of Brown University to the other through the U.S. mails, and there's never any larger package that could possibly meet the USPS specifications of that time. Finally, a knife with 2 blades, because a famous problem in calculus says if you have 2 blades and you cut through a cake, you get a large piece with icing, or you could slice right at the sides of the cake and get a piece that's not so large in terms of volume, but has a lot of icing on the side. And as it turns out, you get the same amount of icing whether you go through the center or whether you go just grazing the side. That was inspirational to Connie Wright, whose father made this 2-bladed knife and whose neighbor made a case for the 2-bladed knife for cutting spherical cakes. Something presented to me by my class back in 1971. So it's really beautiful to see how some of the old problems come back again and again, not just with computer graphics, but with the work of the students who are inspired by them. That concludes our little tour of this exhibit, Beyond the Box, 45 years, among dimensions, among disciplines at Brown University.